Welcome to another webinar from the Philips Lighting Academy. Today's webinar is titled Spatial Light Distribution, and it is presented to you by Martine Knoop from the Berlin University of Technology.
Thank you, Dion, for this introduction. I would also like to welcome all participants to this webinar to the topic Spatial Light Distribution of Daylight Situations as a Reference for User Preference. I would like to start with a short introduction about myself and two of my favorite pictures that show the beauty of daylight. I'm Martine Knoop. I'm a lecturer at the University of Technology in Berlin within the Department of Lighting Technology. I'm responsible for the topic daylighting and interior lighting in both research and teaching. My own research project looks into the unique characteristics of daylight responsible for the user preference of this light source. I want to study these characteristics in order to promote and improve daylight design and to develop new adaptive electric lighting solutions, in the end to enhance user well-being and user performance in indoor spaces such as offices. Well, one of these daylight characteristics is, to my opinion, the spatial light distribution, and that's the topic of today. In general, it's about the understanding of characteristics of natural light to design a new generation of indoor lighting designs. I will address three topics this webinar, and I will start with the impact of LED lighting on indoor lighting conditions with a focus on office lighting. This was the starting point for my research and the reason why I regained interest in the characteristics of daylight. Secondly, I will look into one specific characteristic, with the idea to learn from our preference for daylight, to learn from daylit situations, which are generally preferred over electric lighting solutions. And I will end this webinar with the research of a number of PhD students that looked into or are still looking into luminance distribution and spatial light distribution. Well, all started with a piece of work that I've done within a technical committee of the CIE, which is the International Committee on Illumination. And I looked into the variety of different LED lighting solutions in about 2014. And this is what I found, or this is a selection of luminaires that I found. Although this is already a while ago, the overview is still valid, I think. We can see on the market larger luminaires with large diffusers, which result in which give a very diffuse lighting in the room. And on the other hand, the market offers luminaires with very small point sources that might realize very directed light. If we then look at these luminaires in the application, we see that we can realize with LED lighting solution very directed lighting and very diffuse lighting. One could actually say that in normal applications there is a very broad bandwidth of different lighting conditions that can be offered, and these can affect lighting quality in a way that I think conventional light sources have not done before. Just to give you an impression of these quality of light aspects, very directed light from small light sources can cause very harsh shadows and multiple shadows. And these shadows can impact our visual performance. It can lead to unpleasant appearances of faces of people, and it can be very distracting or confusing for some users, such as elderly and visually impaired people. We can also see that this directed lighting, with which we can save a lot of energy, and I'll come back to that later in this webinar. With this directed lighting, we can really well illuminate the task area, but most of the time the remaining part of the room is not really well lit. So these lighting solutions, the LED directed lighting solutions, do not have the so-called spill light that conventional sources had, such as fluorescent lamps. The fluorescent lamp was is a light source that cannot be directed that well, and we always have some spill light. And although this spill light might be seen as a waste of energy, as it's not very effective in illuminating the work plane, it does light up the room surfaces, and with this, in the end, will affect our impression of the room. On the completely other side of the scale, we have the very diffuse lighting, which we can realize with LED lighting as well, if we put a good diffuser in front of it. And with this diffuse light sources, we realize a completely different room impression. Well, there are some researchers that state that the lighting from a luminous ceiling, which is comparable to these lighting solutions with diffuse LED light sources, improves spaciousness and is exceptionally comfortable. But there is some other research as well. As you can see on this part of the slide, other researchers found less positive responses. The lighting was found to be uninteresting and least preferred. The lack of shadows gave a situation of large monotony and a low degree of modeling. So what you can see from this is that there's very different responses to this very diffuse lighting. And although this is not the topic right now in the webinar, I would like to already point out something that will be discussed later in this webinar. One of the reasons for these differences in responses, in findings, could be actually the result of a missing definition or a description for diffuseness or diffuse lighting. And diffuseness is not properly described, and it cannot be quantified up till now. And therefore the question is, did all researchers that are listed here on this page look at comparable situations, or is the difference in response a result of differences in lighting solutions that were offered to the subjects? What we know in the end is that the quality of light and the response of the user is something that we need to look at. Having this broad bandwidth of different lighting solutions that we can realize with LEDs. One could, of course, wonder if the standards do not already solve this. If the standards offer, if we make a lighting solution according to the standards, if we not offer already quality lighting solutions from the start, if we properly follow these standards. But with a few simulations in this presentation, I would like to show you that that's not per definition the case. So if I start with the directed lighting part in this webinar, and I start with the European standard. Actually, I would like to start with the directed lighting first. If you just consider directed lighting, it's most of the time used to increase energy efficiency of the lighting solution. Well, the standards that are available right now, not just the European standard, but I'll show it here because I'm using that in daily practice. It's available since 2011, and it actually supports to realize energy efficient lighting solutions as well. Not just by defining that we can use directed light sourcing, more actually by offering the possibility to reduce the lighting levels in the surrounding of the task, as long as the lighting for the task is sufficiently provided. For those not familiar with the European standard, the immediate surrounding, as you can see here on the screen, is the area directly around the task area, which is preferably large, but needs to be at least 0.5 meters around the task area. And the background area is the area around the immediate surrounding area. And the average illuminance in these surrounding areas can be lower than the average illuminance in the task area. I'll just briefly show in an example what that means. So just consider a typical standard office room in Germany, Berlin. I have made some simulations to support my point of view. I've chosen this room and I have looked into different task areas or different areas to be lit, and 4 different luminous intensity distributions of luminaires, as you can see here on the right hand side of the screen. Well, in this case, we would assume that all luminaires are being used to realize a general lighting in the room, so the whole area is lit by the same average, is lit to achieve the same average illuminance, for example, in this case 500 lux. And if I would look now at the possibilities that the standards offered me, I could just focus on my task area, have there my average illuminance of 500 lux and reduce the lighting level in the surrounding area, so the remaining part of my room. That's possible with all these luminaires. If I now look at the next solution, as you can see on this screen, I could focus on my task area, reduce the lighting in my surrounding area to, for example, 300 lux, and the remaining area, which is the background area, can have an even lower light level. So according to the standards, that's possible, and that's best done with directed lighting solutions. So it really offers the LED solutions another way of saving energy. What happens with the lighting in the room? Just to give you an impression, this is how it would look like if you would have a typical solution for the office. We have general lighting with a conventional or a normal office lighting solution. And here you can see the lighting solution with directed light, offering the possibility to focus on the task area, have a lighting level on average of 500 lux here, then have the surrounding area here with a lower light level, for example 300 lux, and here the background area with 100 or 200 lux. That's possible with directed lighting. At the same time, you can see from this slide already that the room appearance of this room changes as well. Just to give you an impression about the energy savings, if I now have back to the standard situation where I have 500 lux with a normal office luminaire and I realize 500 lux in average, I can of course reduce my energy consumption if I use a directed LED lighting. Even if I still realize 500 lux on average on my work plane and I keep my uniformity that's required, I can save up to 15% of my energy. If I now look at the solutions that I showed before, reducing the lighting level in the surrounding area, as you can see, I have here task lighting. Around here I have a lower light level. It's the same in the picture here, 500 lux here, 300 lux there. The savings would be in this situation about 40% in comparison to the reference situation. And further reduction is possible, as you can see on this slide. With the proposed reduced light level in the background area, this simulation indicates a saving of up to 75%. And this is one of the reasons why we thought we need to look into room appearance. Because one of our PhD students, and that's Raphael Kirsch, used this at the starting point of his research. He already indicated in 2010 that these lighting solutions might not be comfortable for the user of the room, and not because of the lower horizontal illuminance in the room, but because the walls might become too dark. And this was already used somehow in the EN 12464, which is this European standard, and this standard version of 2011 includes minimum wall illuminances and minimum uniformities, as can be found in similar way in the US Lighting Handbook as well. Looking at the required and recommended values, the standard requires minimum luminances of the wall and the ceiling of approximately 7 to 20 candelas per square meter. If I now look again at the simulations, I have included a luminance map of the standard reference situation with the normal office luminaires. We see high vertical illuminances and thus high luminances within the field of view of the user. As you can see here, we have an average illuminance on the wall of 250 lux, and the average luminance of the wall is about 40 candelas per square meter. If we now turn to the narrow beam situation, as you can see in this slide, you can see that the vertical illuminance reduces. It's 95 lux, still within the standards. So that works well. This is the 500 lux general lighting. If we now reduce the light level in the surrounding area, it will drop to 60 lux on average, as you can see up here, which would mean that it would not be the recommended value anymore. It will be the minimum required value again for this situation. It will still be according to the standards. So the average illuminance value drops under the recommended value, but it's still according to the European standard. This is not the case in this situation. The room surfaces have a very low or average illuminance of 20 lux, which is approximately, let's say, 3 to 5 candela per square meter, way too dark. We see enough light on the work plane here in this area, but this solution might not be accepted by the user. Already said that this is not according to the standard. There's still a reason why I would like to show this. I see on the market an advance of adaptive interior LED lighting solutions, or maybe not on the market, but definitely in research. And adaptive interior lighting solutions might really change this. So just keep in mind that that if you have directed lighting, the luminance of the walls changes as well. So we have here adaptive indoor lighting. This is an example of it, and it shows that lighting is only used at areas where activities are. So we have a general lighting level, and additional lighting is switched on or dimmed up only in areas where tasks are fulfilled. I have another example of that, and as you can see in this picture, you could save up to 65% of your energy consumed for electrical lighting by using luminaires that have a large number of small LED modules that can be directed exactly towards the task. And whereas this is a very energy efficient solution, and I think if you do it properly, it can work very well as well, the illuminance on the vertical planes likely drop, as was already shown in the simulations that I just showed a few slides before. Well, the standards do not address this kind of lighting solutions yet. And the lighting solution as such is completely fine if you look at it when it's in completely dimmed up. It can offer the lighting conditions according to the standards. But for now, there's nothing included in the standard how to look at these cases, at the use cases of these kind of lighting solutions. And therefore, I would like to question if the luminance of the room surfaces should get a more prominent role in lighting design and standards. Well, this was already discussed and questioned in a technical committee that was started in 2010. It's a technical committee of the CIE, the International Committee on Illumination. And this technical committee looked at the applicability and suitability of existing quality measures in situations with LED solutions. So in fact, what we did is we looked at existing quality measures, and we looked whether LED solutions could be assessed with that, if we could assess the quality with that, as the bandwidth of the lighting solution, as already said in the beginning of this presentation, seems to be broader than with the conventional light sources, so more direct or more diffuse. And the question was if problems with LED lighting could be identified with the existing quality measures. So the committee looked at gaps and weaknesses of existing quality measures and gave recommendations for new measured and required research. For those that are interested, the committee has summarized its work in a report. It's CIE 205, published in 2013, and you can find all the details of their work on CIE website. But in this webinar, I would like to focus on the conclusions of interest for this webinar. So the conclusions of this CIE committee was that the room appearance, as well as shadows and modeling, need to be considered in the quality assessment of LED lighting installations. It used to be more important, this is more important in LED lighting solutions than it used to be for fluorescent lighting. As said, the lighting of a fluorescent installation has more spill light. We don't have that many harsh shadows. So that was the reason why the CIE committee said that we need to consider these aspects in more detail. For room appearance, the document proposed to look at minimum luminance values within a 40-degree band of the field of view of an observer. I'll I will get back to this 40-degree band in a second. But looking again at the minimum luminances of the walls from a European standards point of view, the standards proposed wall illuminances of 50 to 75 lux, which is approximately 10, 15, maybe 20 candelas per square meter, depending on the reflection of the surfaces. This report of CIE says we need about 30 candelas per square meter. Therefore, it's argued by a number of researchers that the required wall luminances in the European standards are too low. And the preferred wall luminance of the room surface was one of the main topics of a PhD researcher at TU Berlin, and I will show you some of his results in detail in the coming slides. Well, the committee also indicated that a metric for shadow or modeling or diffuseness of light was not available for LED lighting solutions yet, and I will address that topic after the part on the minimum luminances for room appearance. As you can see from this picture, luminances within the field of view affect our impression of a room. And as said, the technical committee of CIE proposed to look at the average luminances, the average lumens of the surrounding within a part of the field of view. And this was already done by quite a lot of researchers. It was based on research of, for example, David Lowe, Kevin Hauser, Guy Newsham, and Jennifer Veach. If you want to look into that in more detail, you can look for this work. They indicated that an increase of room surface luminance positively affects room appearance. That would mean that a decrease of luminance could in return negatively affect room appearance, and that's what we worry about when it comes to the LED lighting solutions. I said that I would specify this 40-degree band a bit more in detail. This was already proposed by David Lowe in 1994, and it was included in a number of studies, also in the PhD research that I will address in a few seconds. And he actually looks at this area, so it's 20 degrees below the line of sight and 20 degrees above the line of sight. And the researchers say that the luminance of this area is of importance. If I then look at this situation that I was actually simulating in the previous example, we see that we have here a partition, and that the luminance of the wall, but also the luminance of the partition plays a role. This partition was in the simulation way brighter than the luminance of the wall, so the average luminance could be okay again. The luminance of the wall is not addressed in the European standards. It's the illuminance of the wall, and therefore the illuminance of the wall is just partly representative for the luminance within this 40-degree bandwidth. Well, as said, there was research done at the University of Berlin. It was the PhD research of Raphael Kirsch, and he looked at various different solutions. He wanted to know whether if you realize more directed light with LED, can we affect visual lightness and visual attractiveness by changing light levels and luminance levels in the room. For this experiment, he used a mock-up room, of an office, 1:1, scale 1:1, with electric lighting only. The room looks like this. The luminance of the room surfaces within this experimental setup, as you can see here, up here, and here, can be changed separately, as there are LED panels positioned behind acrylic plates. So these are all acrylic plates up here as well, and there are LED panels behind it. I'll show you in this slide. So these are the LED panels. These panels are about 20 to 20 centimeters big and can be each separately dimmed. This allows us to generate any desired luminance distribution on the room surfaces. I have another picture that might give you an even better here it is, an even better impression of the room. Here you can see the LED panels again, and there's this level of acrylic plates in here. And you have here the LED panels as well. So the mock-up room is under construction at the moment, which gave us the opportunity to make some pictures without the acrylic plates. And you can see here the single LED panels that can be dimmed separately. If you look at it in use, the room can look like this. Task lighting is realized by beamers. You can see here 4 beamers in the ceiling. With these beamers, we can realize the horizontal illuminance on the work plane. With this experimental setup, it's possible to strictly separate the luminance of the room surfaces and the illuminance on the work plane. So if we want to study the impact of horizontal illuminance on room appearance, we can adjust the lighting level on the horizontal plane without affecting the luminance of the walls, and the other way around, we can study luminance of the walls without affecting the horizontal light level on the work plane. I'll just give you a few pictures to give you an impression of how that works, and as you can see, we can actually realize almost every lighting distribution, luminance distribution that we would look like. Well, Raphael Kirsch performed his experiments in this experimental setup, and the main research question of Raphael was how do office lighting conditions influence room appearance? And for this purpose, he asked about 100 participants to rate the appearance of the space under different lighting conditions. And these lighting conditions differed in the offered horizontal illuminance, as well as in luminance of the room surfaces. And both parameters were changed independently from each other. So in the first part, he looked whether he could reduce the horizontal illuminance in the surrounding area, in the background area, without affecting the room appearance. And that was possible because we could keep the, so we could really look at, or he could really look at the horizontal illuminance because he could keep the luminance of the walls the same. So he kept the wall luminance the same, just reduced the horizontal illuminance, and found out that reducing the surrounding illuminance to approximately 100 lux only marginally affects the visual lightness, and it does not even affect the visual attractiveness. So that's an interesting issue. In a normal conventional situation, you have to realize that if you reduce this lighting level, you directly also reduce the lighting level on the wall. But this was something that he could look into separately, which he also did. So additionally to this, the horizontal illuminance, Raphael looked at the impact of different average luminances of the room surfaces on room appearance. In the end, actually, because his main idea was if we can save lighting or luminous flux, so to say, can we use that to enhance the appearance of the space by just using this luminous flux for the vertical planes. And what he found was that the lumens of within this 40-degree band are very important, and they are preferably greater than 30 to 40 candelas per square meter. In fact, he found that an increase from the typical European standard levels, approximately 11 candela per square meter to 30 candela per square meter, balanced out the the changes the changes resulting from going from a horizontal illuminance in the surrounding area from 300 to 100 lux. So in fact, he said if we reduce the horizontal illuminance, we can use that lighting to increase visual appearance in the visual lightness and visual appraisal in these situations. He also looked at luminance distribution. I'm not going to discuss that in detail, but because especially since there's more research required, he looked at different luminance distributions, as you can see on the screen. And at the moment, the kind of intermediate conclusion is that visual lightness is highest when we have a uniform light distribution, but if we have a specific pattern or non-uniform distribution, the visual appraisal is higher. So non-uniform distributions are more interesting, but the room might be perceived as less bright. Of course, there are other people looking into the topic of room appearance and luminance of the wall. Similar approach is used by James Duff. He's a PhD student of the Dublin Institute of Technology, and his work is based on the work done by Kate Cottle, who uses the mean room surface exitance as a measure for the perceived quality of light in a space. Well, the mean room surface exitance is the density of reflected flux within a room. And that means that you just look at the lighting that comes reflected from the walls. It's discarding the direct component. And it's derived typically from the luminance of the surface. James has performed experiments in scale models as well in the last year. He offered different levels of mean room surface exitance levels, and observers were asked to look into the lighting booth and judge the brightness of the entire booth from very dim to very bright. And he found that there is a linear relationship between spatial brightness and mean room surface exitance. So both James and Raphael found that the luminances of the wall were very important for the perceived brightness of a space. But they also both confirmed that in their studies that horizontal luminance is not representative for the spatial brightness of visual lightness. If we look at these two pieces of research, one could draw the conclusion that the luminance of the room surfaces need to be included in the standards, and I absolutely agree on that. But the lighting quality of a room is not secured with that. That's at least my opinion, and the reason for that is another experiment that was carried out at our university I would like to share with you. So that's the research of the PhD research of Stefan Gram, and he looked into the differences in visual performance on the light from above, from electric lighting, as well as light from the side, from an artificial sky. So the construction of the artificial sky can be seen on the right-hand side of the picture here. Which you just imagine that you step out of this room, you stand in front of this room and look to the facade. This would be then the facade. We have fluorescent lamps up here above the window opening. And there is a dome here, a white diffuse dome here that reflects the light from the fluorescent lamps into the room as if it is an overcast sky. So the light distribution in the room is comparable to the light distribution from an overcast sky. Color temperature of both the electric lighting and the skylight or the artificial skylight was kept the same, and also the horizontal illuminance on the working plane was kept the same. Stefan Gram conducted his experiments and found that that there was no effect on visual performance. Not really the topic of today, but there was definitely a difference in room appearance. So the participant judged the room differently under different lighting conditions. They said that the daylit room, so with the artificial sky, was perceived darker but more appealing. If we then look at the luminance maps of this experiment and compare that to the work of Raphael Kirsch, we should look at the 40-degree band for the participants in this experiment. And the 40-degree band includes the side wall, the back wall, and of course the facade, and a bit of the artificial lighting. As already can be seen from maybe this picture, is that the average lumens in the daylit room, this is the daylit room, is higher than in the room lit with electrical lighting. Well, the research of Stefan Gram, as already said, indicated that the visual lightness of the room in this situation was perceived less than this one. So this room was perceived brighter, but the people preferred this situation more. So the appraisal of the daylit room was higher. And the question arises then, if the luminance, average luminance is here higher, the room is perceived darker, but people like this one more, there must be more than just the luminance, average luminance of the wall that plays a role in my subjective assessment. So part of my research is to look at the other qualities of daylight that might have caused this user response. Because we know that windows are important, so research indicates that windows are preferred, or actually light from windows is preferred. The view and the provision of daylight are the most important qualities of the window. If we just look at the daylighting, research shows that people prefer daylight over electrical lighting, and they even believe it's better for their health and performance. But what's different with daylighting? Of course, we know that daylight is dynamic in lighting, level and color temperature, but it's too simple to state that it's only preferred because of that. There are a large number of qualities of daylighting that we need to consider, and the thing is, they are probably interlinked, and these interlinking and the effects of that is not clear yet. But there's a number of characteristics that I would like to address in this webinar and discuss in more detail in the following slides. The light source is dynamic in direction of light. It's a large light source, and it provides the room with a specific spatial distribution. If we now start with the light source in general, this is a big light source, as you can see on this picture. And most of the time, these light sources from outside have a fairly low brightness, something between 6,000, 7,000 candelas per square meter. If we look at the luminance maps for 2 dates that we made measurements in this classroom, we see that there is a large light source. The brightnesses are very well spread, so there's a low brightness. There are no harsh contrasts in this situation. The light source has a certain direction as well, and it's dynamic in this direction. You see here 3 pictures of the reference room that I started this presentation with. We have here the situation sunlight and a sunscreen. You can still see here the direct sunlight getting into the room, but that's covered by the screen. This is the sunlight directly in the room, and here we have an overcast sky. So we see a same direction, but here the light is more directed and here it's more diffuse. What we see is that, as said, dynamic in direction, in brightness, but the lighting typically comes from this side and illuminates specifically the vertical planes by default, which is definitely not the case if we look at the electric lighting. As you can see here, the light comes from above. We have a dark area up here, and we have brighter light levels here. So when it comes to vertical planes, which seems to be important for user preference, daylighting has this already by default. I have some luminance pictures here as well. I need to point out that these pictures are definitely not about horizontal illuminances. They do not have comparable horizontal illuminances. It's more about the luminous distribution. It states again that we have higher vertical illuminances in the daylit situation, but when we don't look at the absolute values, we see also a different distribution. No harsh shadows in this situation, a bit more harsh shadows with this because we have direct sunlight, and we have some harsh shadows in this situation as well. If we just look at this lighting solution, overcast sky, the lighting has a directionality by default because we have a window up here, but it also has a diffuse component in it. And that's what I would like to discuss when I come to the spatial light distribution. So if we go back to the luminance pictures of the PhD research of Stefan Gram, As said, color temperature was kept constant, horizontal illuminance was kept constant, but there are three things that really changed. We have a large source here instead of the smaller sources. We have a different vertical illuminance, in comparison to this situation, which might have affected room appearance. And we can see from this picture also that we have very diffuse lighting, but it has a directional component that makes this wall brighter than, for example, the wall here in this situation. As I already said, it has the overcast sky has a directionality because of the position of the window, but it also has diffuse lighting in it. If you would ask people if daylight enters the room, do you have harsh shadow? Most people will say if it's light from the overcast sky, it will be more diffuse light than directional light. And it was research done by Koenderink, who's from the Netherlands, into the sensitivity of people towards lighting, and they already indicate that we have a sensitivity for intensity, direction, and diffuseness of light sources in a space. And if we talk about room appearance or spatial lighting, it's definitely clear that cannot be reflected in the average lumens of room surfaces. And what I think is very interesting is the statement of Schofield from 2011. They say people prefer diffuse lighting with a directional component, which can be found on a cloudy day or from the sun embedded in a diffusing sky. So we need to be able to quantify this directionality and diffuseness to draw conclusions from our daylighting situations that then can be used again to apply in electric lighting installations. If we have this way to quantify directionality and diffuseness, we can further study how dark a wall can be or how diffuse the lighting in a room can be without affecting the lighting quality and user preferences. I see that I have to speed up a bit, so I will just go through the two researchers that I would like to present to you. So CIE did not propose a metric to describe spatial lighting distribution yet, but there are two PhD researchers looking into this topic. They want to try to describe spatial light distribution. The first researcher is Ms. Sia. She's a PhD researcher at the Delft University of Technology, and her work is based on the metric proposed by Kit Cuttle as well. He was looking at the vector-scalar ratio that's being used in some countries to describe the appearance of objects and occupants. And he uses a cube with 6 illuminance measures to describe this lighting, spatial light distribution. And Murray and colleague looked at the spherical harmonics representation of a light field, and Ms. Xia actually kind of combines both ways to look at the directionality and diffuseness of lighting. We have a PhD researcher working on this topic as well. She's looking at directionality of light and diffuseness, and she uses for that the light incidence. So I'll just go through that. That's a way to describe the light direction and also the diffuseness of light in a different way. She doesn't look at vertical luminance or the luminances on a sphere. She looks at the luminous flux entering a solid angle, which is comparable to the representation of a luminous intensity diagram of a luminaire, but then not for the sending luminous flux, but the receiving luminous flux, which is called light incidence. Just to give you an impression of what that would mean, if I have very directed light, that's the situation, very directed light with black walls. I have here a Lambertian luminaire with white walls, and I have a measure point with diffuse lighting all around it, you would get a diagram like this. You can see here directed lighting from above. We get a main component from above, where we get reflected lighting as well, and here we get light from all around it. And with this way of characterizing, we could describe diffuseness and directionality of the light. This, of course, is something that we need to do for daylighting as well. This is what we are working on at the moment. What we see is that we can describe daylight by means of a directional component with a diffuse component. And of course, this will change for different sky types. So it's very sky type depending. What we need now is, and that's the thing that I would like to close this presentation with. We need to be able to describe these daylighting conditions. We need to be able to describe it in a similar way. So in order to learn from this daylight spatial light distribution and to define the boundaries for appropriate electric lighting design, it seems that we need to go back to the basics. We need to be able to quantify directionality and diffuseness of light, both characteristics of light that seem to be specifically relevant for LED lighting solutions. And up to now, these characteristics are hardly considered in research and design. If we can quantify both the directionality and diffuseness, I believe that we can learn from daylight as a reference light source. Of course, I have to admit that the spatial light distribution realized by daylight is just one aspect of daylight, and the other characteristics such as dynamics in level and color temperature, as well as the size of the source, can interlink and can affect the user preference as well. At the moment, unfortunately, we do not have enough results to set the boundaries for too directed and diffuse light, but I could give you some advice at the moment. Please be aware that the luminance of the walls and the ceiling play a role in the room appearance. Please keep in mind that they have to be higher than the ones that are proposed by the standards at the moment. And additionally, I would like to state that people or luminaire manufacturers that look into directional lighting include a diffuse component in these lighting solutions, either in the lighting solution in the room or directly in the luminaire. And with this, I would like to close my presentation. I would like to give you some key references to the work of this. You can have these slides from me if you like to. You can find information in these references, background information also to previous work, as you can see in the upper part. And I would like to thank all of you for your attention.